like to give you as a very warm welcome to today's webinar. Thank you very much for joining us to talk about chemistry for the IB Diploma program. Before I introduce our speakers, I would like to draw your attention to the slide on the screen. We just need to go through a couple of housekeeping matters. If you need to communicate with us, if you got any technical queries, please use the chat box. We'll keep an eye on it throughout the webinar. If you would like to pose questions on today's webinar's topics, please also use the chat box. There will be time for questions at the end of the webinar, and we'll make sure we go through as many of the questions you post then. I know some of us have pre-submitted their questions, so thank you very much for that. We've made a note of those and we'll answer those in the Q&A session. The Q&A session is going to be moderated by Dr. Catherine Barber, who's our IB publisher at Pearson. Catherine only is the IB publisher. She's also an IB alumna. So you'll be in very good hands with Catherine there. Today's webinar is going to last for about 50 minutes and is going 52 minutes to 1 hour. Is going to be recorded, and the recordings will be available at the end of the webinar. And now, without further ado, I'm delighted to introduce our speakers, Mike Ford and Oliver Canning. Mike teaches at the École Janine Manuel in Paris. He has 30 years in teaching chemistry for the IB Diploma, Physics and TOK, 10 years as a coordinator and 20 years working for the IB in a range of roles, including examiner in chemistry and TOK, paper author, workshop leader, senior curriculum coordinator. Mike has also been involved with the last 3 curriculum reviews and is father to 3 DP diploma graduates. Oliver Canning teaches IB chemistry and is the TOK coordinator at TASIS England. In addition to 9 years working in the IB diploma program, he has taught chemistry courses in English, American, and Spanish education systems. He is also a course leader for the educational charity Amala, who works with displaced youth. He was a contributing author to the upcoming chemistry curriculum, as well as developing the accompanying teacher support materials. And now, over to you, Mike and Oliver.
Yeah, good morning, everyone. Nice to know you're there. Just to quickly, the point of today's webinar is to go through a quick overview of the new courses, and also show how the Pearson texts have actually adapted to that. Just to start off proceedings, it'd be nice if you just say hello in the chat with your name and your location and which books you currently use. Do you use the Pearson High Level, the Pearson Standard Level? Do you use both, or indeed do you use none? Do you use another publisher? And it'd be interesting to see which other publisher you use. So that would be useful just to have a sense of who we're talking to. So just to make the point that this is a Pearson webinar and not an official IB webinar. So if you're interested in getting information from the horse's mouth, some of you may have been on IB workshops. In fact, I've just come back from one. I did one last weekend. And the place to go to is the PRC. And you can see the guide in the left-hand column with the detailed information of what we're going to be talking about. Worth pointing out also, the collaborative science project, which we'll get into the details later, actually has a separate guide, which is in the in practice column in the middle. The teacher support material, which will be very useful, is not actually out yet, but it's very it's particularly useful for things like TOK, nature of science, conceptual understanding, things which I'll be Oliver and I will be making reference to during the webinar. And the specimen assessments, the specimen papers, are in the right-hand column, so you should navigate and become familiar with the IB webpage. Oliver, anything to add at this point?
No, yeah, I think you've covered it all, Mike. Thanks.
Great, thank you. Okay, so just to give some sense of what the curriculum review actually entails, because people talk about the IB, and in fact, it's really a community of educators that make the changes, and the IB facilitate that. So in terms of the curriculum review, we look at what teachers say, questionnaires are sent out to schools. There's what's happening in the IB diploma generally, so the IBDP context is also an input. So the move to conceptual understanding has basically had an impact on the reviews of other subjects, not just the sciences. Then we've got general what's happening in science education overall. That comes in, and the IB diploma high-level subjects particularly are really intentionally a passport to universities, so we've got to make sure that universities are also have some input as well. So they're the inputs into the process, and I guess this webinar is going to talk about the output. So what's new? Well, one clear intention of the review from the beginning was the recognition that the content in IB chemistry was very heavy content-wise, and people always, well, I personally struggled to finish the syllabus in good time. Students used to ask me when we're going to finish the syllabus, and I used to reply, well, hopefully before the exams. To give you some metric, it's not very scientific. The current high-level book has 980 pages, and the new book has 945. A cut, you'd say, but of course, the old book actually contained the options, and the new book doesn't. I would say there has been a reduction in content, and we have got a little bit more space to breathe as teachers and for students to reflect. But it will still be, it's pretty jam-packed all the same, but it's very difficult to actually agree on what would have been taken out. Teachers are very keen to add things, but less reluctant, also more reluctant to take things out. One thing to bear in mind is some of the material that was in the options has actually found itself into the core. So I'll give you an example here. Fuel cells, which was in the energy option, has found itself into the topic reactivity, redox, which effectively is a redox chapter in energy, and it's there. So you've got to be a little bit careful. Although the options have gone, some material has found itself into the core of the advanced high level. I think the material that it's found itself in is the good chemistry material, which actually adds to the connectivity of chemistry and the relevance in terms of applications. Some of the inverted commas factoids that were in some of the options clearly has gone, which I think is only a good move. Oliver, anything to add to that? Oliver,
no, I think you covered it.
Perfect.
One thing to say is, from talking to Katrine, the kind of taking some of those bits from the current options just helps students be exposed to crucial chemistry in a slightly broader context instead of being focused in that single option that was chosen.
Yeah, great.
So, which is quite a nice touch, I think.
Yeah, thank you. Okay, so one big emphasis is on the conceptual approach of chemistry, which really is, I think chemistry has done quite a good job on this already, actually, in the current guide, making connections, and certainly the current assessment, it's making connections between different areas of the subject. It's rather ironic being a textbook writer, but when students say, what chapter are we on? My heart dies a little bit, because I think it's important that students don't see it necessarily as just a linear path. By nature, of course, the textbook is a linear path, but they're able to think and make connections between different parts of the course. So dividing chemistry into two simple halves, structure and reactivity, and of course, structure determines reactivity, and then of course, reactivity leads to structure. So it's all intertwined, but I think it's a nice little visual representation of what we as chemists are trying to do. The roadmap is not a teaching order, so there's no need to feel that you have to do the left-hand column followed by the right-hand column. You will find your own way through the course. You will find, I imagine that you will find the current way that you teach the current course, you can actually develop with just a few small changes and teach the new course. But you need to be very clear to the students which topic are you currently covering, because you don't want to zip zap around too much, because they might get a little bit lost. How is the guide? One key change to the guide also is this idea of guiding questions, which effectively are an introduction to what the students are going to study. In the textbook, it's an introduction to the chapter. Why is it worth reading? And very much students students will say, well, why do this? What's the point? Well, the guiding question is actually showing you what you're trying to focus on as you go through a particular area of the course. The syllabus then is set out in a very clear format. You'll notice that the right-hand element that was in the old courses has gone, and some of that material has found itself into the TSM. So there's no now direct references to TOK or international mindedness. That's all to be found in the TSM. So the guide as is clearly shows what you need to teach and what the students will be assessed on. The understandings are the top line. The left-hand side is guidance, which gives you some idea of what could be assessed, references to the data booklet, and the right-hand side, the linking questions, which I'm going to go talk about in a little bit more detail next. So again, in the textbook, we're very clear that we identifying which understandings are high level and which understandings are standard level and high level, or the core, if you wish. So if the textbook has made a very clear point that in the high level book, it's very clear to the student what is high level material. Obviously, Pearson are quite unique in having the standard level book and the high level book as a separate textbooks, if you wish, as a teacher. So standard level students can buy the standard level book. Everything they need will be in that. High level students will buy the high level book, and obviously they need to study everything. Oliver, chip in at any point you feel I've missed out something?
Sure. No, I think maybe one point worth highlighting, having this kind of clear distinction in the HL book when you reach HL only or additional high level content. It's helpful, particularly if you're teaching mixed classes or you have students transitioning at points in the year, so you want to kind of buy a set of the same books. So actually standard level students can use the higher level book because it's very clearly distinguished when they reach HL only content.
Yeah, that's a good point. Thank you. Okay, so the linking questions. I think that's probably, for me, one thing that I think I'm really looking forward to, and that as you go through the course, as you navigate the course, you'll be setting little links between what they've studied and what perhaps they will study, or perhaps what they have, later on in the course, what they have studied and how that links back to what they did study previously. In the textbook, they are clearly marked by the little link icon, as you can see here. So, for example, we have structure 1.1, which is models of the particulate nature of matter, and we've got 2.3, which is about models of bonding, and a question about alloys, which of course are mixtures. So linking up what they've studied about mixtures generally in the first topic to what they're linking up with alloys as an example of a mixture once they've actually got a little bit more context. Students are actually, the idea is, of course, linking questions can go both ways. And, as a teacher, you are free to make up your own linking questions. And as a student, perhaps, you might want to encourage students to make up their linking questions. I think they're very useful both in the start of the course as trying to make students realize that chemistry is a rich network of understandings, and when they look back on the course in terms of revision, that they're able to actually challenge themselves by making up these connections as well. This will of course be reflected in the assessment, where questions will be, some questions, not all of course, some questions will actually be trying to get students to make up connections. As I said, they're placed alongside the relevant text. So as a teacher, you will be able to, as a student reading the text, they'll have a good sense of what connections can be made. And as they read the text, they'll be hopefully reflecting on that. And, obviously, perhaps going to that part of the textbook to see how it relates to what they're currently reading. I think this will become richer as the course develops. Anything else about linking questions, Oliver?
No, I think you've covered it there. Thanks.
Okay, one other change is the idea of skills in the study of chemistry. Now, in the current guide, the legacy guide as we call it, we have the prescribed labs. And I guess one change has been you move from prescribed labs to prescribed skills. One of the issues with prescribed labs is there were 10 or so prescribed labs. And I think the intention was questions in paper 3 would basically be related to those prescribed labs. But you realise pretty quickly that you've only got 10 labs and you've got 3 exam sessions every year. It can become quite predictable. It's the skills that are actually key, and that's what the student should be focusing on. If you look at the actual list of what's required, the ones are basically experimental techniques, input here from universities, universities saying what students who are going on to university should actually be able to do, and simple things like titrations, dilution concentrations, etc. Again, nothing that I don't think any teacher will be surprised by any of the anything in the list. It just makes it very clear as a teacher what you're actually asked to do. It also acts as a passport for students, essentially, in terms of what skills they developed and how useful the chemistry course was. Technology, again, it's no real additions to what was in previous guides, but just very clear as to what the requirement is. And mathematics, whereas in the previous guide it talked about mathematical requirements, now it talks about, it's actually explicit, you know, these are the tools that you need to do chemistry. And in one of the approaches to teaching and learning, inquiry, again, linking up the fact that chemistry, you're asking students to explore, design, do experiments, collect data, and evaluate. And we'll talk about those skills and how they're assessed when we talk about the internal assessment. In the textbook, there are references which support this. In each chapter, you will see on the right-hand side or the left-hand side in the margins, a skill box linked to an icon, and you're able to download resources from the eBook, which will give details of experiments which will support these skills. Oliver, anything you'd like to add at this point?
No, I think if you've got it, maybe just at one point in the kind of the skills chapter in the book, it does indicate where you might be able to explore these different skills in particular subtopics, which I think is helpful, as well as providing actual resources for carrying out particular labs and so on.
Yeah, thank you for reminding me. Effectively, the skills, you've got icons in each chapter, but you have got a separate chapter at the end of the book, which is skills in the study of chemistry. So it's very clear what the student is expected to be able to do. Okay, the other thing to perhaps mention is that obviously in terms of programs of study, often teachers are required to make links to approaches to teaching and learning, and the skill pattern, the skill development does actually fit in quite nicely with the idea of approaches to teaching and learning and the skills that they need, particularly the research skills. In the just going back to the guiding questions, as I said, they're an introduction to each chapter, but they're very useful as a revision technique at the end of each chapter. So we start each chapter with the guiding questions, and we end each chapter with a section called Guiding Questions Revisited, where we bullet point all the things that we're focusing on, a summary effectively of what we've covered in each chapter. In the ebook, the summaries are available as a PDF file, again, to help revision. So the internal assessment, it has changed in 2 ways. Criteria have changed. You've got simpler, you've only got 4 criteria now, each of 6 marks. The personal engagement has gone. It wasn't a very useful assessment tool. Students tended to get a 1, and also perhaps a little artificial response to some of what they're expected to do. Communication has gone, but you'll find it actually embedded in some of the other criteria. One thing to note is that the high-level skills of conclusion and evaluation perhaps have a higher weighting than they did in the old guide. So that's something to bear in mind. Although in practice, when I've done exercises with teachers, I'm not sure it's harder to I don't think the marks necessarily will go down, even though it might be seen at first glance to be more challenging. One thing to bear in mind is that at the beginning of each session, so this will be 2005, when students have actually submitted internal assessments, the grade boundaries in terms of what these marks out of 24 mean in terms of 7, 6, 5, 4, 3, 2, 1 will be set. So if it is perceived that they are more challenging, the grade boundaries can be adapted to accommodate that. In the textbook, you will see that, or in electronic textbook, you'll see that there's actually a copy of a list, a checklist to ensure that students do actually know what's required and to support them in doing that. I think teachers found that very useful in the current text, so we've actually continued that, adapted it to the new criteria. Oliver, anything about the IA?
No, I think all good.
Great. Okay, one big change, which has certainly caused some questions from teachers, is this issue of collaboration is now actually accepted in the early stages of the IA. Now, the first thing to say is this actually is a practical option, particularly for schools that have big classes, limited technical support. And in terms of safety, you know, instead of having, if you've got a class of 30, do you really want 30 IAs happening at the same time? If students are doing similar experiments with similar equipment, then they can collaborate in terms of setting up the protocol and designing what equipment they're using. And they can even help each other perhaps take results. But what they can't do is have the same research question. Now, if as a teacher you're uncomfortable with that, then there is no requirement for you to allow collaboration. It's up to you. It's there as a practical tool to make the management of it a little bit easier, the logistics easier. It's all, I mean, particularly coming from, let's say, biology, where they're doing field work, and it's a little bit artificial to have students doing field work separately, because by its nature, you collect lots of data and you put that into a database, and then students extract from that database what's useful. So that's the sort of model of when collaboration is really seen to be a good option. For the chemistry teacher, I think, you know, some of you will feel it's not really for you, and that's fine. It's up to your individual circumstances and what you're comfortable with, but it's there on the table if it helps. Is that what you would agree with, Oliver, or do we have a different angle on this?
No, I think so, and you have a better kind of big picture view of the three sciences, but definitely, for example, class sets of data leans more towards being useful in biology. I think to do that in chemistry with distinct research questions is going to be a little more challenging to do. So I think it's worth bearing in mind that that might be tailored more for biology, for example, than chemistry. But if it works in your context, then it's available.
Yeah, I mean, this is just my personal view, but I mean, as a chemistry and physics teacher, I don't think I'm going to necessarily allow students to collaborate. But that's just a personal view. Okay. Okay. Nature of Science is still there. The Nature of Science, although it's gone from the guide, it's still there in terms of what we're expected to do in terms of discussions with students. It has been simplified, however, in the guide. So whereas in the current guide, there's sort of a 5-page legal document almost with section 1.1, 1.10, it's now being reduced to, hopefully simplified and clearer, to a table with what I call aspects of science. So it's very clear what students actually are expected to understand by the nature of science. In the textbook, again, as in the current book, there are boxes with nature of science, which again gives some ideas of illustrating the nature of science and how it applies to chemistry. Again, it's no way exclusive. You can think of lots of examples, but certainly as a teacher, you feel free to introduce your own, but the textbook will hopefully support you in that. The sheet support material, which will be on the PRC in September, will give you some more ideas. So although nature of science isn't as explicit in the guide as it was, it has, the intention is that it still will delivered in the same way. Although I know that you're a big fan of nature of science.
Yeah, I mean, I certainly like in the new guide that it's been made much more concise and kind of condensed to a list of whatever, 10, 12 aspects or concepts. And I think particularly from my point of view as a TOK teacher as well, those concepts are really important in kind of making bridges beyond just chemistry to other subjects, which actually is quite rich in terms of student learning within chemistry, but also yeah, a bit beyond chemistry and into to TOK certainly as well.
Good, thank you. Okay, so one other change is the Group 4 project has changed the collaborative science project. It's not a dramatic change. In the review process, when schools were questionnaire about this, it's clear that some schools love the Group 4 project and some schools are less positive about it. But on balance, it was felt that collaboration being one of the key elements of the approaches to teaching and learning, we should support that, and also highlighting the nature of interdisciplinarity in academia and in the workplace. So it was an important thing we felt to keep. We have revamped it though, so give it a little bit more focus perhaps. And whereas in the current guide, ESS students, environmental systems and society students, can opt out, which I always thought was a bit ironic given that it's an interdisciplinary subject, they will now be expected to take part, although their guide is 1 year behind the chemistry guide, so it will be in a year's time that their guide talks about the CSP, as we call it. As I said at the beginning, the CSP actually has a separate guide, so you won't find it detailed in the chemistry guide. So you need to go to the CSP guide, which is in the middle column of the PRC. What's essential and what's required? Well, it involves all students, all science students as before, lasts at 10 hours as before, opportunity to problem solve and inquire as before, collaborate as before, communication as before. This issue of a local context is perhaps, some schools have done that, but it's again important in terms of what the IB education actually means, linking global with local. So that's required in the CSP. On the right-hand column, we've got the desirables, which I think hopefully some teachers will aim for. Students working across subject matter, links to TOK and CAS. That's again some interesting material in the TSM highlighting how you can do that. And again, making it fun. So students actually presenting their ideas in a range of formats, including journals, podcasts, posters, etc. So hopefully you will be reinvigorated by the CSP. It's also linking up to things like citizen science, the UN Sustainable Development Goals. So giving students a sense of that they are going into a world where there are lots of global issues, and if they can try and think about those and how they can relate to what they do locally, that's essentially what we're trying to do. You do have to write a 100-word reflection, which is a 100% increase because currently it's a 50-word reflection. This reflection won't be assessed and it only needs to be kept in schools. You could be asked for it at some stage if your school was going through a 5-year evaluation. Okay, but nothing to worry about. It's just something to capture, reflection being an important element of the learner profile, and the student should actually think about what they've been doing. Any thoughts, Oliver?
No, to echo what you said. I think it's been revamped a little bit in a good way, and hopefully people can find some kind of creative and enjoyable ways to carry it out in their context.
Great, thank you. Okay, so what's the same? When we're talking really about the text, so the PSOW has been recalled the Record of Experimental Program, so it's really stayed the same apart from a different title. Again, it's for internal use only. But it's good as a teacher to keep a record of practical what you've done, and also just in your head keep in mind that the skills that you're supposed to cover as well. Record of experimental work should be rich enough to ensure that the students do get a range of skills needed. The global context, again, is in the book as before. Again, links to environmental, political, economical considerations, importance of chemistry in international context, and some reference to cutting edge chemistry, which will hopefully enthuse students who are going on to do chemistry or other sciences in the future. Key facts are there as before in the textbook, focusing again on identifying what's really important for the students to have an understanding of and a good point for reference. So it's very clear for students to find them in looking at the margins of each page. Hints for success. Again, this is, I think they're called examiner's hints in some editions of the book, previous editions. Again, helping students have an understanding of how to approach questions and common pitfalls, and perhaps clarifying what can be assessed as well. In the textbook, there's also a separate chapter on strategies for internal assessment and external assessment. And as you can see, I've got the table here, which you can see there is a change to the external assessment in that paper 3 has gone, partly because the options have gone. And what is currently paper 3A, the data-based part of paper 3, has effectively now become paper 1B. So paper 1 is one paper, but it's got the 1A, which is like the current multiple choice paper, and 1B is the 3A and the current guide. But it is one paper, so students will have to manage their time so that they do the multiple choice and then they go on to paper 1B, or perhaps they do it in reverse. They could do 1B first and then the multiple choice. It's just one paper with 2 sections, so they're free to go through it how they wish. It's because it's one paper and they need the calculator and the data booklet for paper 1B, they actually have access to those for the multiple choice, which means some of the questions that could be asked, like patterns in periodicity, will now not be that valuable because they will have the data booklet with them. So there will be implications in terms of the questions that will be set on the paper 1, although the format hasn't changed. Paper 2 is very much as is. Notice now that the 2 components are actually quite nicely balanced. So that will help students if they have a bad day, hopefully won't be have such a bad impact as in previous assessments. Oliver, any additional thoughts?
No, I think you've covered it. It's a bit of a change, but it's similar style questions, just in different places. Again,
in terms of the style of questions, I'd invite you to look at the specimen papers, which are on the PRC. In discussions I had with teachers over the last month or so, I think they recognise that the nature of the question hasn't actually changed dramatically. I think chemistry has always been quite good in setting questions in a context, but then drawing out conceptual understandings on different contexts. So I think that will continue. Okay, also in the book we have challenge yourself, which are effectively questions which are there for get students a little bit think out of the box a little bit, thinking more depth, and perhaps go beyond the syllabus. So the example I pulled out here, I know I had the person who checked my questions was a little bit bemused by it, wasn't quite sure how to answer it. What would be the shape of the periodic table if we lived in how is it related to a 3-dimensional world, and if we lived in a 2-dimensional world, how would it change? The idea being that if you had 2 dimensions, you wouldn't have a Z direction, so you wouldn't have 3 P's, you'd have 2 P's, and you wouldn't have 5 D's, you'd have 2 D's. So the periodic table might actually change. Just a bit of fun trying to get the students to think out of the box. Other questions will be, just encouraging students to really challenge whether they fully understand something. A good tool, hopefully, for differentiation in the classroom. Oliver, anything all challenging?
No, nothing extra to add.
Great, thank you. Okay, interesting facts. Again, things which they're not required to learn or memorize, but things which add a little bit of colour, flavour to the course. So background information, historical information about the life of scientists and original ideas, and perhaps any interesting connections. The idea is just again to make the book a lively read and draw in the students so they enjoy studying it. I know these are very popular with teachers and students. I think there was an intention to increase the number of questions in the book this time, so that's partly why the page number has gone up. Well, it's quite high considering the options have gone. Questions come in different types. You've got the worked examples where we go through the solution in detail. We've got the exercises which are permeated throughout the chapter. So if they've read a section of the chapter, they should be able to answer the following questions. And we have the questions at the end, which are effectively exam questions, which the students should be familiar with in terms of preparation for the exams. These practice questions are IB questions, so they're good, they're realistic examples of what a student will be asked to do. One thing I should have added at the beginning, this edition of the book has now got the IB stamp, so we are officially an IB textbook, which hopefully will show you that we're on the right track. Unofficially, I know the person who reviewed the book told me that he's going to recommend the Pearson book for his students. So we've got the official recommendation, but we've also got the personal recommendation of a friend who actually reviewed the book. I didn't know he'd reviewed the book beforehand, by the way. It was just after the event, so there's no funny business going on. Okay, TOK. I think Oliver and I are both keen TOK teachers. I mean, we'd argue that all IB teachers are TOK teachers. And I like the idea of this equilibrium between chemistry and TOK, how chemistry can enrich TOK and how TOK can enrich chemistry. In the book, there are references in each chapter in the side columns about how things in the text can link to TOK. Again, these are not exclusive. You can probably think of some equally good links yourselves, and again, perhaps bring students into the discussion in your classroom. But also the book has a TOK chapter which starts with a picture of the London Underground, because I like the idea of mind the gap, because to me TOK is really getting students to recognise that in making a jump to make a knowledge claim, they're actually doing it naturally, perhaps not fully recognising the implications of what they're doing. So that's why mind the gap for me is a useful image of what we're trying to do in TOK and chemistry. Your TOK teacher, you might want to add something there.
I mean, the only thing is probably that this chapter might be equally as helpful for teachers who are not familiar with the TOK course as it will be for students in trying to find those links. I know TOK can appear a bit distant sometimes if people haven't become familiar with it. So I think it's a good chapter to read as a teacher before the course to get a bit of a flavour of what TOK might look like in the classroom in chemistry.
Right, thank you. Yeah, I think some teachers perhaps see it as an additional burden. I would encourage you not to see it that way. I think it can actually enrich your classrooms in terms of discussions. And a key point would be it would also support your students, because your students are doing TOK, and if you look at the essay titles that they have to work on each year, this year, for example, one of the questions was the need to how to reproduce data, which ties in very nicely with what they're doing in their internal assessment. They need to repeat experiments to get reliable evidence. There's also a chapter on the extended essay, possible approaches to the extended essay, useful for the students to read if they're doing chemistry extended essays, hopefully some useful guidance for teachers as well. We've also put a little bit there about world studies extended essays, because if you look at the top 10 subjects which are popular for extended essays, chemistry is not in the top 10, but in world studies is. So it's worth thinking about perhaps a student doing a world studies extended essay with some chemistry connection. Again, I think different schools take this to different, unless they're more familiar with it. Some schools are very familiar with world studies. I know some schools where all the students do world studies extended essays, but some teachers perhaps haven't really quite got to grips with it yet. Again, the IB PLC on the extended essay area has some excellent support material on this, but the book does give you a little bit brief overview of what the possibilities are, just so that you're aware of those. The book also has a final section on green chemistry. As chemists, we are increasingly aware of our impact on the environment. Students often feel chemistry is a chemical is a bad thing, but obviously chemists are the people who are going to solve a lot of these environmental issues, and green chemistry is something that is becoming increasingly important. Certainly, my career as a teacher, it's really changed how I do things and the scale in which I do things, and how students think about solving problems and making them responsible citizens. So there's a little chapter there to support you in that. The ebook, so you'll have access to, apart from the textbook, is the paper copy is written very much in terms of the guide, covers all the guide and the questions as we discussed, but the ebook has more. So it's got detailed suggestions for lab work, as I referenced when we talk about skills, links to videos, auto-marked quizzes in the exercise tab, and the answers to the quizzes as well, and the exercises and the practice questions. Okay, Oliver, do you want to add anything?
No, nothing to add there, Mike.
Great. So I think I've covered what we intended. So do we have any questions in the chat that people would like to ask?
We do have some questions. Please continue to ask your questions as Mike and Oliver answer these. So the first question is actually kind of one for me. It's just about availability of the books and the extra resources. So the books are all in the warehouse. They are ready for you to purchase. Some of you, it seems, are already using them, or have them. So that's excellent. In terms of the ebooks, so the ebooks are live, but they do not have the extra quizzes, work solutions, downloadable lab worksheets, and all those things. We're adding them at the moment, and they will all be live by August at the latest, and they'll just be added to your ebooks. You don't have to do anything, they'll just be added as they become available. So that's it on that question. Some questions for Mike and Oliver. So please, could you clarify on linking questions? What happens if the linking question is in a topic not covered yet?
Oliver, do you want to go for that, or do you want me to answer it?
If you want to take it, Mike, go ahead.
Okay, I mean, that's a good question. I think, as I sort of suggested when I went through the presentation, the linking questions when you start the course might be a little bit intimidating because it's they don't quite know what it's linking to or what the implications are of that. So as you go through the course, you'll increasingly use the linking questions more and more. So I wouldn't get too worried about the linking questions. And of course, they can be addressed in the beginning anyway. But of course, we can go back to the linking questions as you cover the second subject. So I think don't get too worried about that or anxious. It's just something to add richness, and as the course develops, students will make richer connections between the areas of the course. I hope that's answered your question.
Thanks, Mike. There was another kind of not technical, but another question for me about the free trial. So Ryan is saying that they were only able to see one chapter. So I think, Ilaria, if you could put the link to sign up to the free trial in the chat, that would be excellent. So we have free trials of the ebooks that are available to sign up for. They are 60 days, and they are only the ebooks themselves. They are not the extra resources, because those are all downloadable. So we can't really give them away in the free trials. But we do also have some sample unit plans for one of the topics that Katrin, one of the other authors, wrote, and I'll also ask Ilaria to add the link to those either in the chat or in the follow-up email. And there's some sample lab PDFs with that sample unit plan content. So please do take a look at that. Ilaria's putting the links in for me. Thank you very much, Ilaria. Another question for Mike and Oliver. So I think this is about the exam papers. Somebody's asking, is IB free response? So can you just, for anybody that's kind of new to teaching chemistry, talk about what the 3 exam papers are, like the multiple choice, etc.?
Yeah, okay. So basically paper 1 is a combination of 2 parts. 1A, which is multiple choice, So each question has a STEM, and then students are expected to choose A, B, C, or D. In the IB, there's no penalty for getting it wrong. So it's not like the US system where you have to be careful sometimes. And the intention of the paper one is to cover the breadth of the course. And the number of questions in the exam paper should reflect the time allocation of the different understandings in the guide. Paper 1B, which is still part of the same paper, so it'll be given out at the same time, is effectively looking at assessing the skill part of the course, which I referenced earlier. And effectively, if a student has got a good lab program, they should be in a good position to do well on that paper. So there'll be questions about uncertainties. There'll be questions about choice of apparatus, perhaps. There'll be questions about graphs and how to deal with data. So again, it's supporting this idea that chemistry is a practical program, and it's important that students develop the skills. One question I think came before the presentation was about demonstrations as opposed to practicals. Well, chemistry is a practical program. I mean, I have taught physics, math, and chemistry, but by choice, I'm a chemistry teacher for that practical element, that students actually get the opportunity to try out their ideas by doing experiments. To me, that's what makes chemistry special. So that's paper one and paper one, which is two parts, 1A and 1B. Paper 2 is really going into it's really testing the depth of understanding. So it won't necessarily cover all the course, but it will cover a good part of the course, perhaps sometimes in a context. They'll set up a context and they'll draw understandings which could come up from that context. So that's where understanding the links between topics is particularly useful for students. So detailed calculations where you'll have a little box to fill out your answer. Could be 2, 3, 4 mark questions, so that students actually show their understanding. Oliver, you want to add anything on that one?
Yeah, just going back to the question about doing practicals or videos, I think there was a question specifically about, is it better to do a demo live or show a video? And I think it obviously depends a bit on time and context, but where possible, doing a demo live allows you to pace things so that you can kind of address and answer questions or ask questions of the students. So where possible, certainly in my practice, I will try and do a demonstration so you have that freedom of pace, whereas video is a little bit more difficult to perhaps do that.
I guess you could always use the videos as support material afterwards, so that they can always revise from it if they so wish.
Certainly, and there are some things on video that you simply can't do in a lab, of course.
Yeah, and also local circumstances as well. All of us have different constraints where we're actually working.
Indeed.
Thanks both. There's a couple of follow-up questions on practicals and exams. So to clarify, is 1B free response or multiple choice?
It's free response.
Okay, thank you. With the inclusion of data-based questions in paper 1, are these types of questions included in the book?
They are. Yes, I think they are. The topics that led to lots of experiments. So, for example, the energy topics, enthalpy changes. The questions there very much reflect the sort of questions you could get in 1B, and the rates, I imagine, as well. The rates chapter. The topics that lead themselves to experiments that lead to data analysis, they're certainly in the book.
Thank you. This might not be a question that you can answer. Do we know whether the exams will be sat in order?
So sat in order.
Yeah, so like paper 1, paper 2.
I'm guessing paper 1 will be before paper 2. Yeah, effectively there'll be 2 sessions. One in the current, you have each subject tends to have 2 sessions, a morning and an afternoon. And I think recently paper 1 and paper 3 were sat together in one session, and paper 2, because that was a longer paper, was the second session. I think now if you look at what's happened this year, you can see effectively that it's really paper 1A and 1B in one session and paper 2 in the next session. It'd be a bit weird to have paper 2 before paper 1, but who knows? I'm not officially. I can't guarantee that.
Yeah.
But,
so for practical work, are there like time allocations for each topic? Is there expected amount of time for practical work for each topic?
There's a time allocation in total for the practical work, but obviously as a teacher you are free to choose which practicals you do. I think some of the topics, as I've said, are more experimental than other topics. So kinetics, enthalpy are going to be topics with you're going to have quite a lot of practical work, but there's no restriction on that. And just to bear in mind, it's not just the skills that you should be looking at as well, because one thing to bear in mind is when you do the internal assessment, you want to ensure that students have been exposed to a sufficient range of skills so that they can actually do a good job of the internal assessment.
Thank you. So somebody's asking if they can still use past paper questions. I'm assuming that's because the curriculum's changed. Like, can you still use past exam papers to prepare your students?
Yes, you can. I mean, the nature of the questions has not changed radically. So the questions that you've used in the question banks are still very good teaching tools. And I think multiple choice papers are great in terms of diagnostics in class discussions as well. So certainly you can use them.
Thank you. Do either of you or both of you have any advice for implementing the IB philosophy into the chemistry lessons for new chemistry teachers?
Well, the easy answer to that one is go to a Cat 1 workshop set by the IB. In this sort of short answer is, I think chemistry teachers are the best teachers to understand the diploma, because we all know about benzene. We can draw a hexagon with a circle in. So I call, the students should be delocalized knowers. They should recognize that they know things across different range of subjects and be able to draw connections between them. So, as I also, and Oliver as well, have intimated about TOK, very much critical thinking, one of the elements of IB mission statement. That's also into chemistry. International mindedness, one would hope that the examples we choose are not just focused on a particular historical part of the world. We bring in new ideas from different parts of the world all the time. So obviously, if you are new to this IB, it's a little bit of a challenge and a little bit frightening, but you will get support sometimes from the textbook in terms of what we've written in the global context, and in the boxes, TOK, etc. But you'll also get support from the teacher support material that's coming out from the IB in September.
Thanks, Mike. Oliver, did you want to add anything to that about the IB philosophy?
No, I mean, in the new guide, there are some kind of, for example, the IB learner profile is broken down to give some kind of slightly more specific examples of what that might look like in chemistry. Some of them are broad enough to cover other subjects, but there's some start points in the guide itself. But definitely the teacher support materials, I think, will be helpful when they're released.
Just to underline that with a point that came up in a workshop this weekend, is that teachers tend to rush to the syllabus part of the guide, and they're not necessarily read the first part of the guide, when it talks about the IB learner profile and conceptual understanding and international mindedness. So you do actually get quite a lot of support in the guide itself, although I can understand teachers rushing to the chemistry content first, but when you have a quiet moment, read through the part A of the guide and you'll see a lot of support there as well.
Thank you both. Shalini is asking, is Pearson planning to come up with its own question bank anytime soon? So the answer to that is no, we're not planning that at the moment. There's lots of practice questions in the new editions, and we also have the auto mark quizzes, which will be added to the eBook access soon. So we're not planning anything beyond that at the moment, but thank you for your question. We don't have anything else at the moment. So this session has been recorded and there will be a follow-up email. Ilaria, do you want to say anything about that?
Yes, of course, there'll be a follow-up email to you all with a link to the recording, and also there will be a link to a very quick survey so that if you like, you'll be able to let us know whether you enjoyed today's webinar, and we really will appreciate it if you could quickly complete it and let our speakers know the great job that they've done today. I'm also going to put in chat links to our website, to our contact us page. Your local educational representatives' contact details are available from this page. And alternatively, if you would like to get in touch, I've included in chat an email address so that you can use that to contact us. So I think this concludes our session for today. Thank you very much to Mike and Oliver for such an informative session, and thank you very much to you all for attending, and have a good rest of your Monday and a good rest of the week. Thanks very much.
Thank you.
Bye-bye.
Bye.
Bye.
Bye.